This is the Science Show on URN.
We're going to do a live experiment. So in the other side of the glass, we should have Hina. Hello, can you hear me?
Hi guys.
Oh, this actually.
Hello.
That's a relief.
Can you hear me?
Yep. We can hear you loud and clear.
That is a relief. The joys of modern technology. All right, so I've only got a pane of glass in front of me. All I can see look like some scalped pumpkins, and you very terrified in a lab coat. What on earth is going on in there?
I just feel really dressed up for this occasion, I'm not going to lie. Yes, we have 2 pumpkins, the product of Carl's magnificent carving skills. They're definitely going to scare all the kids as they walk past. So this week's experiment basically is going with the theme of Halloween, and because chemistry is so fabulous, we're gonna show you the power of an acid-base reaction.
An acid-based reaction?
Yeah.
That sounds kind of terrifying.
Sounds like she's trying to drop the base, doesn't it?
It's just...
Oh my...
It's good stuff.
Someone had to get a bad joke in.
So, what on earth are you doing with pumpkins, vinegar, and base?
So, Carl has very kindly loaded up these pumpkins with some of the base, which is the bicarbonate of soda. And what I'm going to do is I'm going to add in some of the acetic acid, or the vinegar, and hopefully we'll get some sort of reaction. And before I get going, I'm going to explain a little bit about the reaction. So typically we all learn in school that when you add an acid to a base, it's a neutralisation reaction and we get water as a product. But this is quite a funky little reaction because it's a 2-step reaction. Now what will happen is the acetic acid will react with the sodium bicarbonate and we'll get sodium acetate and something called carbonic acid. Now this carbonic acid is an intermediate, and because it's so unstable it decomposes into carbon dioxide and water. And hopefully, because we're going to also add some washing up liquid, the carbon dioxide is going to get trapped in the washing up liquid, rise all the way up to the top, and then spill out of the carvings, hopefully. Fingers crossed.
Okay. Do you want to give it a go?
Okay, let's give it a go. Fingers crossed. Right, I'm going to go in this one first. Let's add it in.
Oh, what?
That is insane. That's really good.
It's the pumpkin just spewed. It looks like blood.
Food colouring helps. But you can see like the carbon dioxide bubbles are getting trapped in the washing up liquid, and because they're heavier than air, they float to the top.
Okay.
And because Carl has been so kind and damaged this pumpkin for us in the form of dodgy eyes and a dodgy mouth, it's all spilling out really nicely. And we'll try the same here. We'll see if it happens again.
I wouldn't mess with Carl's knife skills.
Really?
He will make a mess if you wind him up again. Here we go. What's going on?
What's going on?
I don't know.
Oh.
I can't see what's going on. There's a misplaced head. There's just fits of laughter going on. Can someone explain what's going on here?
This is again a testament to Carl's dodgy carving skills, because all the froth is actually meant to... Oh, there we go! We have some dribble from the nose. This pumpkin has a massive cold, everyone. So this is just dodgy carving skills yet again.
Has he done
the reaction actually works, but yeah, the incisions haven't been put through the pumpkin properly. But the reaction is working, guys. That's a good point.
That's well, at least, do you know what? For our first attempt at doing a live experiment, it hasn't. Well, no one's dead, which is an improvement.
That was all right.
Yeah,
you know.
I can imagine now with all that vinegar, it probably smells pretty funky in it, especially because you seem to spill it all over the floor by the looks of things.
Well, we have got some plastic sheets covering the table, so equipment is not damaged.
Great. So
all is good. I'm alive.
Congratulations on recreating that bit from American Psycho.
Thank you very much.